Critical Thinking Rule 8, use representative examples. This rule is about getting examples that represent the population that you're generalizing about. A representative sample is one in which the properties of the sample have the same pattern as that of the whole population or group that you're trying to generalize about. For example, if you were trying to test the generalization, all Americans eat fast food, and you only interviewed people who were standing in line and in and out, that would not be a representative sample. Almost everyone in line there plans to eat food at that restaurant, which is a type of fast food. Maybe there's a few exceptions, like people who are doing delivery or pickup for other people, but most of the people are going to be fast food eaters just based on where you're getting your data from. So that's an extreme case of a non-representative sample. Non-representative samples are called biased samples. Another example would be psychology studies about human cognition or personality or other factors that only use college students as subjects. This was one of the traditional criticisms of psychology, is that it was possible that many of the studies were biased because all of the subjects were taken from college campuses. This is not universally true of psychology studies, but it happened quite often. And not every psychology study that uses college students is going to have a biased sample, because sometimes the characteristics of college students are not significant for what's being tested. But you can imagine other cases where college students, maybe because they have a higher average IQ than the general population, or they're from a different socioeconomic class than the general population, that might bias the results of certain studies. So that's the sort of thing you need to keep in mind when you're looking for examples to help support a generalization. There's something called a random sample, which is one of the best ways, or probably the best way, to try to guarantee that a sample is representative. A random sample is where each population member has an equal probability of being included in the sample. This is useful because by definition, it eliminates sources of bias or possible sources of bias in the sample. So if you wanted to figure out, for example, what the average American opinion was of the President of the United States, ideally, you'd like to get a random sample of people from all across the United States. So every resident of the United States has an equal probability of being included in your sample. Another example could be if you're trying to figure out the average weight of people in the United States or some other country, and you created a random sample where every person has an equal chance of being measured for their weight. Now, the thing about random samples is, even though they're kind of the ideal case, they're often the best possible chance we have at creating a representative sample, they can still be biased. So this relates to the fact that arguments by generalization are not valid. There's always some possibility that the conclusion, our generalization, could be false, even if all of the examples we're giving, which are our premises, are true. And this is just because it's possible that our examples don't fit the pattern in the population as a whole. So suppose you want to know the average height of Pasadena City College students for some reason or t'other, and you did a random sample, which would probably be very difficult ethically and logistically. We'll get to that in a sec. But suppose you're able to do that. Well, it's possible just through dumb luck that half or a significant percentage of people who land up in your sample could have a feature such as being on the men's basketball team. People on the men's basketball team have a much higher average height than the population as a whole. And the point is, random sampling generally does a good job of eliminating possible sources of bias, but because it's random, it's always possible that you could get a cluster of people who don't represent the population as a whole. And I say people here, but remember, sampling can apply to any group of things, not just people. It could be any type of physical object like water molecules or animals or whatever. The other thing about random sampling is that it's often impractical. So it could be too costly or literally physically impossible to do. So here's an extreme case. Suppose we're trying to study quarks, tiny subatomic particles, and in order to create a random sample of quarks in the universe, we have to be able to travel to the whole universe and access remote parts of it, which is physically impossible, at least given current technology. So in some cases, it's physically impossible to create a random sample. In others, it's just impractical. Suppose we wanted to look at a random sample of quarks across the surface of the Earth. Well, not all areas of the surface of the Earth are equally accessible. Suppose you randomized 1,000, 10,000, or 100,000 locations in the Earth. Some of those might be on the surface of the ocean that could be very costly to get to. So you don't want to do a study that costs millions or billions of dollars. So there's many cases where random sampling is just not practical. Random sampling can also be unethical, especially when you're looking at human subjects. So suppose you wanted to figure out what the average weight of humans is, or the average weight of just people in the United States, like in my previous example. Well, if you had a complete list of the names of residents of the US, that itself could be impractical to get. Suppose you draw 100 or 1,000 names from that list, and you somehow track them down. Then what happens if they don't want to cooperate with your study? They don't come voluntarily. In order to get data from them, you'd have to force them to participate in your study. So suppose Jeff here, he doesn't want anyone to know his weight. Maybe he's embarrassed about it or whatever. So then we'd have to what? Kidnap him, drug him. It's an absurd scenario, but the point is random sampling is often difficult with humans because of ethical reasons. And this can happen with other types of things too. Next up, Rule 9. Background rates are often crucial. Background rates give you context to assess the meaning and validity of a generalization.